What I want to do is just continue where I left off. And one of the things that I had meant to do was actually put a whole bunch of security templates in where what I think is, the best practices for securing your devices, which include your firewall switches and your routers, and that would include Cisco's, Juniper's, Extreme switches, checkpoint firewalls, some Microsoft stuff if you're using it, and some other stuff. Now the problem is that, my company's me. And I've been literally not really working on anything except for my book for the last 10 months. And, I've been relying on people to get me just access, maybe for a couple of hours for some of their devices. And unfortunately, even though they said yes and da-da-da, and by the time I pinged them again, they're like, oh, shoot, I forgot, and, whatever the excuse was. So, Cisco's I know inside and out. I have worked on Juniper's, but what I'm going to do instead, just so you're not confused about this particular hour and a half, is I'm going to just continue with talking about auditing and intrusion detection system stuff. I'm going to go through really more of a conceptual what you need to do as a bare minimum to secure your devices. In terms of the actual configurations, like here's what the commands would look like for different devices, I will not go through that today because I don't have them in a slide. However, what I will do is I'm going to put them in sometime before I go to sleep tonight, and then as I send Susan the slides, okay, which I've already been kind of yelled at for not having, so I apologize, but I figured for today, you can just look up here. But you will have them hopefully by tomorrow morning, right, and definitely before you leave, right, at the end of NANOG. So, they will be up on the website. So everything I have discussed, as well as I'm going to try to cobble together, and grab a hold of the people that promised me access and didn't, and see whether or not either I can do it from here or just, put something together so that there's also some possible templates for things like Extreme switches and maybe NetScreen firewall devices. But remember, what I'm doing is simply for those people that, you guys are all busy, you're running your networks, you're probably not only doing stuff with security, that's probably just one of your responsibilities. What it is a matter of, looking at, okay, I should be securing my access. All right, well, here's my device, and what is it that's available to me, right? So in everything that we've talked about already today, if you've sat through the past 3 hours, you should be very well aware that if you can configure SSH, do that. If you configure one-time passwords, do that. So, I will go through the trouble and try to actually put together some templates because I realize that most people, it will take some time and they will not do it. You guys will not do it because you don't have the time at times. So I want to make it simpler for you, okay? But I will not have the slides in the next hour and a half. So some of it will be there. And I also, if any one of you, feels very strongly, and they have some templates, hey, let's share the information, because that is really what this whole NANOG conference is about. And when it comes to security, it's really, really important that the sharing of information does occur. So, if anybody has other templates, let's get them out there somehow. So, cool. This thing's up. To figure out where I left off. Okay. That's where I left off. Somebody did mention that, I'm pretty bad at actually self-promotion, and I did mention this book. I will have a pointer as to where you can get it. It's actually called Designing Network Security. And I started writing an internal paper on security for Cisco in 1997 because the company was kind of confused. Security pieces were all over the company at the time. And so now they've gotten better. They've actually, consolidated most of the security stuff under sort of one reporting chain. But I started teaching security because I recognized that for somebody, especially network operators, to understand how to secure their networks. When their management says, oh, secure our network today, they have to read about 5 or 6 different books, if not more. So what I was trying to do is kind of create one book so that people can understand the gist of security, get enough detailed information that they get some technical information, and they have, you know, they then know what could be appropriate in their environment and what the right questions to ask are. So the first edition was published in 1999. It actually did fairly well. I never even, you know, promoted it or anything, and it got translated into 8 languages. So a lot of people have said, hey, it's pretty useful. And then a year ago, I decided that I really wanted to concentrate solely on consulting with security, and I decided to update it. So it's just finished, and you can actually get it on Amazon, and if you order it now, it's actually 30% off. So, you know, if you find it useful, great. I'm actually going to have 2 or 3 copies. This is the version just before the last pass, so some of the drawings are kind of weird and, you know, wrong. But if you want to take a look at it just to say whether or not you would think it's useful, you know, I have a couple of copies. You can just look at it, and if it is, great. Now, I mean, you can't take this, but, you know, you can at least say, okay, maybe I'll order it. So, anyway. So, auditing tools. All right. This is something that people sometimes overlook, and more because, okay, when you audit, I mean, what do you do? Oh, and you know, excuse me, I should create the slide here. Slideshow. Okay. Because usually, okay, you're securing your network, so you finally figured out, and you know, you've gone through all your meetings, and you've decided that, okay, we want to authenticate, and you know, we want to configure our devices this way, and this is our policy, and then you finally configure it, and you know, you're secure. Yippee. Now what happens is that how do you know that you're secure, and how do you know that, you know, you are not under attack, that there is no security breach? Because sometimes, you know, things happen, you don't even know that they're happening. You don't know that somebody is just doing all kinds of reconnaissance attempts in your network to try to ascertain more information to get to some critical piece of your network, right? Because, I mean, attacks don't just happen where it's a massive denial of service attack one day and you're completely taken out. Well, yeah, they happen as well, but there's all kinds of categories of attacks. So I don't know how many of you are familiar with the book The Cuckoo's Egg, right? It was written like 87, 88, around that time frame, right? Cliff Stoll. And it was one of the first books that talked about, you know, computer security threats, you know, incidences, and something that was actually prosecuted. How he actually started on his path of going after the people that, you know, were causing a major security breach was he found a 2-cent accounting discrepancy. Okay, and he was just kind of curious. He's like, huh, that's kind of weird. Why is that going on? And so as he started investigating, it led to this huge trail. Where in the end, if I remember correctly, it was this huge group out of Germany, right, that was causing some major security issues. So, you know, accounting, very important, and it's very important that you are, you know, fairly thorough in keeping track of information and looking at the information so that if something looks kind of strange, that you then go ahead and analyze it. Now, of course, the problem comes in is who the hell has time to do that, right? I mean, most people don't. But whatever you can do to automate it, you know, there's new products that are continuously coming out to help with that because people are recognizing that this is a big issue. A lot of ISPs, especially the ones that have been around for years and years and years, have their own ad hoc, you know, stuff that they've cobbled together because it hasn't been available from vendors, you know, but they can't maintain it because, you know, guys leave and then nobody knows exactly what does what, you know. Sometimes you do, hopefully you do. But so it's better if you buy it from somebody else, you know, it's actually supported. So, I mean, auditing tools are extremely, extremely important because maybe not when everything's running great, but once you have an incident, to actually figure out what happened, why it happened, so that it won't happen again, and to actually convict and prosecute people because there's financial liabilities that are at stake here. You know, it becomes really important. So, of course, what kind of data you collect and how do you correlate all this data? I mean, even if you're a small ISP and, you have 3 routers and, I don't know, 2 access servers, a bunch of cable modems, I don't know. The problem is if you have more than 2 or 3 devices, right, I mean, and they're different, how do you correlate the data that you're seeing? And at this time right now, it's really hard, because at what point do you then look to see whether or not you might have an intrusion or whether or not you have a security breach? Right? Do you look at all of your Unix machines? Do you look at all of your switches and routers to see, what the logging trends are? And it really depends on how big you are and whether or not you have personnel in place. But most people will not have a dedicated person to look at these log files, which for any kind of medium or large company, I don't care what business you're in, you don't have the time to do that. And it's one of the reasons that, intrusion detection systems started coming into play a few years ago, because essentially they provide your first alarm, right? Like saying, hey, I think something wacky is going on, and should this be happening in your network? Now, the biggest problem with intrusion detection systems in the real world are that you really have to tweak them appropriately so that you don't get literally thousands of alarms per day where they say, hey, I think you might have a problem, hey, I think you might have a problem. And what ended up happening is that most people ended up spending a lot of money on intrusion detection systems, and they ended up not being useful. Right? I mean, I'm sure if you bought an IDS system about 4 or 5 years ago, you're in that space. Now, they've gotten better, right? They're improving on it, right? The whole thing of false positives, like, how many times does it cry wolf? And then, I can't deal with looking at it anymore because I got too many other things to do, right? And you're chasing down something that's not really a problem. But intrusion detection systems, I think, are pretty important. And as they get better, it's not something that you should discount. Because again, they give you a view of what is valid traffic or invalid traffic actually into your network. So just keep it in the back of your mind, but just follow the trends. I mean, I'm a very strong believer of always having an intrusion detection system at the perimeter points of your network. So for the ISPs, that would be at, where your customers interface to, your ISP core around there. So more around your edges. Because typically where the ISPs get burnt are, your customers who are probably not that knowledgeable, okay? I mean, usually the ISPs have the clue factor, especially in running networks, because that's, their primary thing, what they do. So you get some kind of, attacks typically from your customer networks. So anything coming in, how do you tell that an attack is in progress, right? There's some great things happening, especially here in the ISP community, where, people are letting each other know, hey, I think an attack is in progress. People are starting to make relationships with other ISPs so that, there's this whole word of mouth going on. But I think that you also need to have some kind of electronic surveillance to kind of see what's happening. So, of course, the issue is that an IDS system is, software. I mean, it's hardware and software. So that is also susceptible to attacks, right? So if you're employing any of these infrastructure devices, and typically, when a lot of people talk about ISP infrastructures, you're basically talking, or you mean, routers and switches, and maybe even, your email servers and web servers. But firewalls, IDS systems can also get lumped into that. Right? And you always have to look at, okay, what is this device, what is it susceptible and vulnerable to? So I always say, trust but verify. And I believe Reagan was one of the first to actually, say that, and everybody's quoting him and all that. But in security, that's a very, very, very important thing. It's like, trust what you're doing, but check on it, verify it, audit it. See whether or not you can actually attack your infrastructure and use the tools that are available. And so, an IDS system, for example, I mean, a lot of them run on TCP/IP stacks, and they're vulnerable to any kind of TCP/IP issues, right? I mean, there's been all kinds of stuff where fragments and sending packets that have like weird flags in them and stuff that they cause systems to crash. And there have been a number of papers written on IDS limitations. And one of the things that I always encourage people to do is, especially when it comes to security, I really dislike it when vendors do the marketing FUD with security issues. Because for me, in security, the important thing is to understand your vulnerabilities and your limitations. Because then you can put procedures in place to mitigate any kind of issues or attacks that happen. And if I don't know that, then I'm running more or less blind. So in security, I want to know what kind of issues and problems there can be. And so with intrusion detection systems, if any of you are more interested in some of the limitations and some of the things that need to be overcome, these are pointers to some papers. A lot of equipment vendors are now also incorporating some kind of intrusion detection functionality into their devices, right, routers or switches. That can be kind of useful because why buy another device that, again, potentially can be under attack, or you have to worry about redundancy and availability and all that kind of stuff. I mean, who wants to put another device in your data path? So it could be useful to use an IDS function that's incorporated into your devices. However, the caveat is that it's not going to be a full-blown, right? Usually what vendors do is they take maybe the top 20 signature attacks and then incorporate that in. So at least the exploits that are more widely used, or seem to be the most popular, those can be detected by these devices. So just remember your trade-offs, right? So if you want to at least want to mitigate the most popular attacks, but you're not too worried about, mitigating all of them because you think you have other procedures in place that can deal with that, then you might want to think about turning on the intrusion detection capabilities in devices. With the switch or a hub, right, there's the issue of, are you actually going to see all the traffic or not? Right? With switches, you probably won't. You won't unless, there's a special functionality in there for it. Because what is a switch, right? Basically, you just see traffic on one port. It doesn't broadcast out. So there might be issues with that. So what people have done is they've created all kinds of interesting variants so that you can maybe put a tap on, and then you can, put an intrusion detection system and have all the ports from a switch, so it actually listens to all the ports and all that. I think that's a little bit convoluted, and again, with intrusion detection system, I think for an ISP, you want to see what kind of traffic is coming in. If you're in a fairly small environment, right, just put some checks in place so that you can see what kind of traffic is coming in from your customers that might be a little bit strange, especially, and sometimes even if you do, everybody has management network trends, right? You have to, because how else are you going to bill, right? I mean, I don't know any ISP that doesn't have that. So what you can do is just kind of see, well, it's kind of weird if, your traffic spikes up, right? And then follow that. But well, I will reiterate this more and more. If you at all can, right, security is becoming more and more important because you can lose a lot of money if you have some kind of security incident and, the availability of your network is not there. The industry as a whole, and this is vendors as well as you as ISPs and anybody else that deals with security, the problem is that everybody thinks it should be free. The vendors themselves may not allocate resources or money to people that deal with security because they can't see any revenue streams. Same with companies, they won't allocate more resources to their security departments because they don't see how that's going to help in any kind of way, right? I mean, conceptually, that there's an issue, But what you need to do is, give people like real money numbers, and that, hey, monetarily, it's all about risk assessment when you're buying insurance. So anyway, I go off on tangents with that. So back to the real stuff. Collecting incident data, right? So let's say that you've discovered something like strange, and you've actually determined that, shoot, we are under attack. I mean, I see that, somebody's gained access to my network that shouldn't be, because I've talked to everybody, and something really strange is going on. How do I then deal with this? And one of the first things that you do is, you really do not want to shut down the system or pull the power cord, right? That's kind of instinctual, because you're like, oh my God, I don't know what kind of damage they're going to do. And this again brings me back to something that I mentioned in the very first 10 minutes, which is you need to have some kind of a policy in place that talks about, incident response. And for all of you guys in this room that are responsible for handling an incident and dealing with networks, and troubleshooting it and maybe turning off, some connectivity, you want to make really sure that your boss and his boss and whatever, all the way up the management chain, has signed something so that you're not going to be a scapegoat and will get fired because you decided that it was in the best interest of the company to actually turn this customer off. Okay? I really think it's extremely important to understand that. And, and then you can go about saying, okay, you guys are the experts, you're trying to figure out what kind of data can I collect so that I can stop this security breach without causing the greatest amount of damage. So if I look at, the bare minimum that you need to look at to secure your networks, right? So you've just, you've understood for a long time that, yes, okay, I've got to secure my infrastructure, and I've done some stuff, but did I really do what I needed to do? A lot of people talk about, bogon route filtering and black hole filtering, and that is extremely important as well. But what I think is really important, to make sure you have the basics in place. The real basics, because it's the very basic stuff that a lot of people, especially the little kids out there, are trying to exploit on devices because it's easy. Right? So you want to make sure that you have authentication mechanisms in place and keep track of who has access to infrastructure devices. So for all of your firewalls, for all your switches, for all your routers, make sure you configure SSH. Make sure that you configure one-time passwords. Right? So if I'm logging onto a device, that instead of having this password that I use over and over again for 6 months, that I actually use a one-time password. It buys you more security. And right now, I can't think of a single reason why people would not use that. And then make sure that you tie in, some kind of access control and accountability, which is what your AAA mechanisms gives you, right? Your Radius and your TACAX Plus. And the biggest, thing that I always hear, when people say, oh, I'm sorry, I can't afford it. I'm like, well, Radius is free. There's a lot of freeware versions out there for both Unix or NT. And so I don't think that's really a very good excuse. And if you're in an ISP that, you're going to stay alive for years to come, hopefully you'll grow. So it's much better to actually go through that learning curve now when you're smaller, and really keep the good practices. And that reminds me, and I want you guys to be honest, how many of you use Microsoft somewhere in your network infrastructure? Your mail server, your web server, your Radius server? All right, some of you. The thing is, it's all kind of things about, Uncle Bill's software, and yeah, it's got issues. Every vendor's stuff has issues. And I always really dislike when people say, well, go to Unix, because quite frankly, that's not going to be a solution. Okay, because no matter what, Microsoft is not going to go away. So I would hope that the community as a whole would at least help to figure out how to mitigate some of the issues that, good old Uncle Bill is causing, rather than just saying, sorry, switch your platform. because some people just don't have the money to do that. You know, and you made one decision, you know, maybe it wasn't something you would have made, but there's a lot of that stuff out there and it's not going to go away. So the thing is to be wary and keep aware of what's out there, and then figure out, you know, what is your exposure and how can you mitigate that. So as a bare minimum, device security, okay, and this includes your servers, right? So your mail servers, your DNS servers, all that. I mean, make sure that you restrict access, who has access to these devices. If you configure access remotely, right, through SSH or trusted hosts. So, you know, if you have 1 or 2 machines that are in a NOC somewhere, you know, maybe what you want to do, because you don't know or you can't control where some of the people that control some of these devices are coming in from, maybe you don't trust them that much. You should, okay, or you shouldn't, I don't know. But again, it's a business, so maybe the better policy is that you actually have these filters in place so that if I'm a router, I know that the only person that can, you know, SSH to me or have, let's say, HTTP access is from host 144.254.1.3, okay, because that's the only way that me as a router, you know, somebody should have access to me. And, you know, yes, this is, you know, getting into the real paranoid realm, but in many environments, you really should start thinking in a more paranoid way. Disable access that is not used. So if you never ever look at a router or the configuration through the web, turn off the HTTP server. You know, just disable it. Some devices have it on by default, some devices have it off by default. So whatever device is part of your network infrastructure, you have to understand what's on by default or, you know, not. And, you know, hopefully vendors are starting to get better in terms of reporting that. You want to make sure that your timestamps are accurate, right? So configure NTP, and all of the devices configure NTP authentication. Right, and again, what NTP authentication is, for those of you that have been here for, you know, throughout the day, basically what you're doing is you're proving data origin authentication, right? So that, yep, you know, this NTP server is actually the one that's giving me my time, the one that I'm you know, supposed to be getting it from. And also, any keys that you need configured, any shared secrets, make sure that in configurations you keep them confidential, okay? And for those of you that have Cisco equipment, that's a no service password or service password encryption command, right? Which basically is a command that then goes out and encrypts all of your shared secrets or your keys. And this includes your NTP authentication, your you know, routing MD5 authentication, your username, passwords, like everything in the configuration, so that if you had to send that configuration to somebody, none of your secrets or your shared keys would be in the clear. And I believe Juniper has a command as well, I can't remember offhand what it is, and that, you know, also encrypts it or actually creates a configuration where none of these keys are present. And be aware of that, because you don't want to inadvertently, you know, send out configuration information to people, especially to vendors, if, you know, for some reason they're helping you troubleshoot an issue, because you don't want anybody else getting access to any of your passwords or shared secrets. So at a bare minimum, right, every single devices, you should think about these points. That is a very bare minimum. You know, then of course you have to think about other things depending on whether or not you have layer 2 or layer 3 devices. And some things that, you know, are part of the infrastructure and that really need to be thought about is, you know, DNS servers, right? Like, what do you do? I mean, there are security breaches that can happen, you know, caused by DNS, also with email servers and email. Lame delegations are bad. Rob Thomas sends out, or, you know, Team CYMRU, I believe that's what it is. You know, they have this whole pointed to like lame delegations. So name servers that have, you know, that don't resolve correctly. And I'll tell you, I mean, I will speak from my own experience here. One of the reasons I'm changing my current ISP is not just because, you know, they don't believe in Unix at all and they don't believe in one-time passwords, you know, or anything like that, but I found out that my own personal domain was part of a lame delegation list. So I'm like, all right, I haven't worked with DNS in a while. Okay, what exactly is it? So I spent about half an hour cobbling together all the information and all the pointers, and I sent it to my ISP folks because I sort of know their clue level at this point. And I figured, okay, you know, this is not a good thing. You know, you could have some security issues, and you know, maybe you could deal with this. And I didn't hear anything for 2 days, so I finally called them, and I'm their user from hell, right? But I don't know anything, according to them. So, you know, I called them up, and the guy just kind of says, well, yeah, I got what you sent, and it's a whole bunch of numbers, and I didn't really get it, and, well, I don't really care. And that's when I made the phone call to say, I'm switching. Because the thing that annoys me the most, it's not when people don't understand, you know, and, you know, I mean, who has the time to really spend as much time as maybe I do to read about security stuff? They've got other things to do. But if there's an issue and they get pointers and they don't care, I have a huge problem with that. And if they go out of business, I don't care. Because they could potentially cause problems with their upstream providers and propagate this stuff all over the place. So if you are part of a lame delegation list, or you know, are hosting sites and have that, please, 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 you know, at least take some time to figure out why it's happening, because part of the reason why it's happening could be causing some other security issues down the line. Recursive DNS is also bad because you can cause cache poisoning. Right? I mean, DNS runs on UDP, and it's trivial to actually, you know, spoof the packets. So one thing that would be probably useful to do is, when you're filtering, block traffic to destination port 53, right, DNS, and allow traffic to source port 53, so to a source DNS that has already an established connection. Right. So think about that. And well, for email servers, you know, spam attacks are getting worse and worse and worse. I'm just listing 2 pointers where you know, there's a lot of useful information for how to deal with spam abuse. And I believe tomorrow there's also going to be a session that will deal with email spam. So now we're on to this session. All right. So what do you configure? Again, device security, right? Device security means who has access, okay? Either physical access or logical access. Extremely important. And again, if you think about what authentication mechanisms you use, okay, the reason that I always say use a one-time password is because I want to make sure that I use an authentication mechanism that cannot be easily spoofed, right? And if I'm using a password that I maybe change once a month or once every 2 months, I'm still leaving myself open that somebody can actually either, you know, put some software in place on a machine where they track your keying sequences and they see what your password is, and you're leaving the window open. So if you have a one-time password, that mitigates some of these attacks, and you're just going to be much more secure. And remember, in your environments, right, I mean, your network infrastructure is your bread and butter. That's your business. You do not want to have people destroying your network infrastructure. So again, a one-time password, right, again, another thing that people talk about as well, what happens if I have to carry around this token card and then I lose it, right? Well, what you have in place is a backup method for that kind of a scenario. So your primary way of getting access is this one-time password, and you require people to carry around this card. And then if for some reason the card breaks, you sit on it, you know, you lose it, I mean, who knows what happens, or, you know, it just kind of goes haywire. You then have a backup mechanism, maybe a shared password, that then sometimes gets used only in the event that it's absolutely necessary, and then you change that, you know, once the card gets fixed. So, you know, again, one-time passwords. Filtering, right? I am a very strong proponent that you always configure some kind of filtering. Okay, maybe not at the core, right? But every ISP has a core and an edge. Where your edge is may vary. Okay, you have to determine that, but I think it is very important for everybody to be a good network citizen, right? And make sure that denial of service attacks are not propagated throughout the rest of the internet. Okay, and the one draft that I alluded to before that Bill Manning has written, I was looking up what it's called so that you would know, but it has to do with IPv4 addressing that's delegated by like INA. Okay, if you just do a search in the IETF and the drafts and look for Bill Manning, okay, you'll find a draft that basically says, you know, how to deal with certain IPv4 addresses delegated by the INA, and I'll have a pointer in the slides on that. And that basically will show you what you should be filtering just at the edges to stop really ridiculous spoof traffic from propagating through the internet. And, you know, if you can do it at your customer points, all the better, because you don't, you know, you want to stop that kind of traffic at the points, at the closest points to their origin. And if that's the least you can do, that's great. And I do know that Juniper routers actually have a specific filter already defined, like Bogon filter or something, that lists those. And so all you have to do is apply that to an interface. With Cisco's, you actually have to create that yourself. All right, routing security. MD5 authentication exists, configure it, but be very careful and understand what would happen if you wanted to change the keys. All right, so it might cause some issue if, let's say, you have, you know, 50 routers or whatever, and you want to change the keys. Like, what happens? You know, does your routing actually go down for a little while, or, you know, is there a good way that the vendor has handled the changing of keys? And again, I will make that point that some people have thought about and are thinking about maybe it's useful to use IPsec authentication for that, because in IPsec it's much easier to do to renegotiate new keys. All right, so we've talked about denial of service and incident response. All right, so just to reiterate again, right, generic device security checklist, console access. Never assume that people cannot get into where your devices are, right? I mean, just put in all the security measures that you can. So for console access, a lot of people still leave their timeouts to be, you know, 0, so that if they're sitting in front of the console, that the session will never time out. Well, you know, you never know when you're sitting there and you have to run to go to the bathroom, or somebody's calling you for something and you leave it open. You know, just, it's not good practice, and I would just really, really be careful. Make sure that if you're not using any session for, I don't know, probably a minute, that's probably a good number, you know, that it times out. And, you know, maybe 3 minutes is better for you, I don't know. But don't leave it to just for the session to just, you know, never time out unless you actually log out of it. It's not good practice. Okay. So if you're dealing with layer 3 devices, aka routers, you want to also look at doing black hole filtering, routing authentication I talked about, filtering ICMP, and then having other filtering templates. I think it's useful to have templates for filters. And, you know, depending on your environment and who your customers are, depends on what kind of templates you have. Filtering, again, it's a very hard thing to define a best current practice for filtering, because the networks that people support, and especially from an ISP, they can really vary very widely. What the most important thing that I can state is that if there's well-known attacks, and there's a lot of exploits with ICMP, that, you know, you look at what are some kind of good filtering techniques to maybe put in just for a certain time frame when you know that an exploit is happening. Because an ISP should not be the network police. Okay, I think there's going to be a lot of talk in this, and you'll hear a lot about it in the next 2 days. My personal opinion is that no ISP should be a network police. You should be passing traffic through, and that the education has to happen at your customers. And maybe collective you as ISPs need to become more active in actually educating the customers. Now, some of you are, and then you get customers that don't care, right? So what do? Oh, well, your customer can go somewhere else. You don't even want them, right? Because they're going to cause you headaches. That's not really a great answer either. I don't know what the answer is, all right? Something will have to be done in the industry, because as we've seen, especially in August, right, there's a lot of huge problems coming down the pipe with people creating these viruses and exploiting attacks that can cause issues throughout the whole internet. So also be careful about, not filtering everything and being really careless about what you filter. The biggest thing with ICMP is people say, okay, I'm going to just filter out all ICMP, I'm not going to allow it. Well, that's not really a great solution either, and you're actually breaking the way the internet is supposed to be run. Okay, so there are certain ICMP packets that can be filtered and other ones that should be let through. And again, I'll point to Rob Thomas, because he has done a lot of wonderful work creating templates for what is appropriate to be filtered. If you have a device that's working at layer 2, so basically a switch, besides all the generic device integrity and security checks that you should put in, two things also, maybe you want to put in MAC filters. But remember that, MAC filters, a MAC address can be spoofed fairly easily too. So, is it worth the headache or not? I don't know. Depends on your environment. But the biggest thing I think to look at is the port authentication, which a lot of vendors have had proprietary solutions in the last couple of years, but now the standard 802.1x is out. And so what you can do is, before a device actually connects to a certain area of the network, right, it attaches to the switch. The switch then talks to some kind of back-end server, typically Radius or maybe a TACAC server, authenticates the user, and then allows access to the rest of the network. So I think that could be a very interesting thing to look at. All right. So what I now have, and I want to again just kind of gauge how many people would find this interesting, is I have some slides that basically try to make configuring IPsec a little bit easier, okay? Because the biggest problem is the different configuration options that you have, the different defaults, and the different terminology that people use. So I have about 10 slides, and how many of you would like for me to go through them in any kind of detail? All right, it's about half of you. So I will do that, right? Because as I talk to people, a lot of people are interested in IPsec. They sort of maybe spend 2 days, touch it, they get it to work, and they leave it alone because it's such a pain, right? And, when they go back to it again, they're like, I forgot what this was, but it works. So let me just go through this, and maybe, the more you hear it, like some of it will start making more sense. Because to me right now, it's become a very easy process, because there's really only 2 or 3 things that I need to consider. And for those of you that might not have been here earlier, if you are interested in IPsec and you maybe haven't configured it, and you have a bunch of different devices that you're looking to maybe create VPNs for your customers and all that, there's a wonderful site called vpnc.org, okay, which stands for the VPN Consortium. And it's run by this guy, Paul Hoffman. And what he did a while ago was he started there's some section in there that basically says, okay, configuration examples. And what it is everybody that's part of the consortium was asked to provide a sample configuration for a specific scenario. And the scenario is IPsec tunnel mode going from gateway to gateway. And it's using pre-shared keys and then also digital certificates. So I actually did the NetBSD one about 1.5 years ago. And that's kind of started it off for him. And then there's probably a slew of 15 vendors, okay, that have sample configuration examples. So that way you can get some kind of interoperability between two devices and you don't have to go around figuring out, most of it on your own. So again, vpnc.org. So all right, yeah, I think the vendors have made it really hard, okay, to do IPsec. I believe that a big issue is that, they should just have similar defaults, and that somehow, somebody should pick, okay, these are the parameters that you should have for IKE Phase 1, IKE Phase 2, go with it, and, if it doesn't meet somebody's requirement, no, you're not defining their security policy because it's a default. They can change it. But at least for most people then, hopefully, they don't have these configuration nightmares. And I'm always a proponent that whatever the default is in security, a lot of times it can be the strongest algorithm, because I will make the assumption that, the hardware and is fast enough now to handle that. Of course, if you have very big pipes and you're trying to encrypt everything, no, I'm wrong. But, I always want the defaults to meet at least 80% of, user requirements. Then I'm happy, because that's a pretty large chunk. So this was taken from what Paul Hoffman defines for his configuration for the VPNC. And I looked at it, I was trying to figure out, why did he pick these numbers? And I'm like, it's not actually too bad. Because triple DES for encryption, right, that's pretty good. And basically everybody supports it, right? AES is becoming the standard. Now, keep in mind that IPsec standard itself, they still define DES, right, to be the mandatory to implement for encryption. And it's been deprecated by the, US government and all that. But so triple DES is picked because basically most people will support that. You might want to pick AES if your vendors or whoever you have and you're doing IPsec all support that. Okay, but that's why triple DES was picked. The lifetime can vary. And, they're usually set in seconds. So I forget what the number is, it's like 14,440 or something, whatever. But it's how many seconds is one day. That's what you set your lifetime to. Then SHA-1, when, this is another IPsec thing, which is really funny. Some devices just say, so do you want MD5 or SHA-1? So unless you know the IPsec standard, how do you know what that's for? Why should you know what SHA-1 MD5 is, right? Oh, well, it's, what kind of hash function do you use? How do you do integrity check, right? Origin authentication proof. Well, I don't know, I'm hoping the vendors will change their configuration stuff, but so some people say, what do you want to use for, your hash function? Other people just, the vendors just say, well, you can pick SHA-1 or MD5, and you have to figure out, oh, okay, I know the standard enough, I know that means integrity check. But SHA-1 is thought to be a little more secure than MD5, so that's a pretty good pick. And then Diffie-Hellman group 2, Cisco's say mod P, go figure, and Diffie-Hellman group 2 means that you're choosing a larger prime, so 1024 bits. And so these are pretty good parameters. So depending on what the default is for your device, you may or may not have to change them. Again, the thing is that both ends have to be the same. So I would recommend these parameters for IKE version 1, IKE phase 1. And then for IKE phase 2, basically the same thing. The one thing that you can do for IKE phase 2 is you can configure something called perfect forward secrecy, PFS. And for those of you that might not know what it is, it basically means that you will always generate new keying material. Right? When you want to create new keys, so your lifetime expires, right? And what a lifetime is, how long do your session keys, how long are they valid for? So, okay, I said, they're going to be valid for 8 hours. So once 8 hours are up, just before that, the algorithm or, me as a device, I'll be smart enough to regenerate new keys to then, after 8 hours to start using to do my encryption for confidentiality and my data origin authentication. So the way that you can derive these keys is you can either use the shared secret that you derived the last time, or you can just completely forget anything that you've done before, create a new shared secret that will then derive your keying material. Okay? And that might be confusing to some people. You have to think about it for a while to really understand it. Because what happens is that when you use Diffie-Hellman to create a shared secret, that's not the shared secret that you use to actually, encrypt your traffic. What that shared secret does is that's an input to another algorithm that then creates your keying material, and from those keys, that's what you use to actually encrypt your traffic. So, a little funky, but it's always good to at least configure perfect forward secrecy. Okay, the only damage that it will do is that with a Diffie-Hellman computation, you will use some CPU cycles as you create your new prime numbers. And if you use a very small router that has very little CPU cycles, maybe that will cause an issue. Okay, but if it doesn't, there's no reason not to do it. So my recommendation is always configure it. If you find it to be an issue, take it out. All right. This slide here, basically it just shows what you can think of when you filter. And, all right. The interesting thing about this is, all right, corporate campus, this could be your NOC, right, or wherever your central location is. Now, if you're just, a smaller ISP, that's maybe all you have, and you don't have any branch offices in, some other city. But if you're larger, you might. And also, you're going to be connecting to customers. So don't worry too much about, whether or not I say internet or branch office or whatever. Just think about, okay, you've got these different clouds that you're connecting to. But the one in the middle, the corporate, that's your core, your central network. And anything connecting to that are your network edges. Now, I'm always a proponent to have ingress and egress filtering. So you have filters going out from your corporate network to your customers, and you have filters from your customers coming into your ISP network. Now, one of the things that you need to be careful of is that if your customers use RFC 1918 address space, right, so basically the legal, illegal addresses, I love saying that, but these are the addresses that you should never actually see propagated through the internet. You want to make sure that, you stop any traffic that could be using these addresses from the closest point of origin. Right. So I would probably say, from the router there that's on branch office B, from my interfaces going out to the internet or to the corporate campus, I would have some filters that say, I don't ever want to see this kind of traffic. Right. So that's not a bad thing. The problem that you have, though, sometimes, and you have to be very careful with filtering. Filtering at first can seem easy, but then after a while, you can really confuse yourself, right? Because, you really have to understand where all your traffic is going. And if you have back doors, right, and back doors being, if your primary connection goes down, there's an alternate way for you to get access to a certain part of the network, right? You don't want your filtering to be such that you're closing the back door, right? So you want to leave that open. I'm seeing a lot of kind of either confused stares. So, okay, let me think if I can put it another way. But basically, the internet there, okay, the way I've drawn it, it should just be one cloud, right? Because it's all part of the internet per se. And what you have with your corporate campus, you essentially have a route to the internet from the router to the left, but you also have a route to the internet from, going through branch B, right? And so what your primary route will be going to the internet will be going through the router to the left. Now, if you apply certain filters there so that you cannot get to address 192.150.42, then if for some reason the connectivity goes down from that top router to branch office B, then if there's some hosts from that corporate network that need to get to those, 192, 150, 42.0 hosts, then you won't be able to do that from the other way because you're filtered out going that way. So filtering can become extremely complex, and especially because most of the time, right, we're multi-homed. I mean, we don't want a single point of failure, whether it be device or connectivity. So that's where filtering becomes really black magic. And so you really need to spend some time thinking about what you're filtering, and it's not really a very easy task. I mean, it's very easy to make mistakes. And one thing I will also mention is that I don't understand why vendors do this sometimes, but a long time ago, Cisco bought this company. I can't remember what the name was now, but it was like in the late 90s. And what that company did, they had this one product that was really cool. It would go out and it would check your router configurations, and it would kind of create a topology for you. And then it had some software where you could say, all right, so, I've configured these access lists, and you could say, well, can traffic go from network A to network C, or network, A to network Y? And based on the topology created from the configuration in the access lists, you can then check whether or not you've configured the access list correctly. Well, the salespeople didn't know how to sell it, so they got rid of that product. Right? Now, from an operational point of view, I thought it was such an excellent tool to actually validate and check whether or not you configured your filters correctly. I mean, I've been up at 2 in the morning, just changing one filter, and of course, you put it in the wrong place, and you're there for 5 more hours trying to figure out what you did wrong, and you basically typed 17 instead of 170. Right? I mean, if you have multiple entries there, I mean, it gets pretty easy to make these little mistakes here. And so, if tools like that become available, look for them, grab them. And whenever I see them, I mean, I try to make people aware of them. At the time I worked for Cisco, and they didn't listen to me because the salespeople couldn't figure out how to get money, from this product. But anyway. So you will have these slides, again, hopefully tomorrow morning when you look on the web, they'll be there, because I do want to add stuff to it. So, but these, and you can look at them later. I mean, these are just from the other example beforehand. These are some sample filtering rules that I would put in. Now, the only difference in most networks that maybe you would have, I mean, these would be the no-brainer filters, would be that when you see the addresses, the 171.71 or the, I guess, 144.254, those are my network addresses, right? And those you would replace with whatever you have. But a lot of these numbers, like the loopback interface, the 127, or the 10.0 address, 172, and the 192, those are the RFC 1918 addresses. And then some of the other ones were added from, what Bill Manning's draft recommends. So these are just kind of like what the overall policy is. And then, you've got, here's like a configuration. And this particular one is if you had a Cisco device. I mean, that's the syntax for them. All right. So as a summary, I mean, really, and what I want you guys to walk away from is to understand that the most important thing that you can do to secure your infrastructures is to make sure that access to your device is as secure as you can make it. Okay, that is step number 1. Nobody except for the people that you think should be authorized to have access to them should have access. And what that means, I mean, if you're really paranoid, okay, instead of just having a user access, also control which machines they can actually initiate the connection from. Okay, in some environments, that has become extremely critical, and some people fire people who do not do that. Right? I mean, it might not be your environment, but think very strongly about that. I mean, security is becoming more and more critical, and especially for ISPs, I mean, you cannot afford to lose trust from your customers or, you know, to get these lawsuits if you've got some kind of breaches. So your core infrastructure, do the best you can to control who has access to the devices and have accountability to them. You know, provide the best level of authentication that you can. One thing that happened, you know, it's so funny, social engineering. I mean, people usually get access to infrastructure devices because of really stupid things. You know, either there's no physical controls in place and, you know, somebody's impersonating a worker, or what's really funny, I mean, I've been in this situation a number of times where I'm in a hotel and, you know, there's people talking, they're like, hey, you know, I don't know, for some reason, you know, can I use your computer? And, you know, the guy's like, yeah, sure, my login name is this and password is that. You know, I'm just kind of standing in the background, you know. I'm going, wow, you know, I can't believe these people are discussing this in front of me. I mean, they don't know who I am, right? And no, it's not here. It's not like at a geek conference. But, you know, it's incredible to me how many times people just talk about their password out loud. And it's not so hard, you know, for me to figure out maybe who they're working for and, you know, try to gain access like that. So, you know, people have to understand, too, that they need to keep this stuff secret. All right, you want to filter at the edge, use route authentication, and also audit your network infrastructures. Right? I can't stress auditing enough because I would hate for any one of you to be in a situation where, you know, you've been breached, you don't even know it for months, and then all of a sudden something happens where, you know, you end up going bankrupt. So auditing, it's tedious. Who wants to do it? Who wants to stare at log files, right? But you have to have something in place as a sanity check so that if there's something weird that's going on, you know, and hopefully you're curious enough to wonder, why, you know, why am I seeing that traffic? Like, what is somebody trying to do? Oh, and I go on tangents all the time. All right, so the next 6 slides are basically 6 steps for if you have a Cisco router and you're in a Cisco environment, how do you configure IPsec? And, you know, what do they mean with their terminology? So step number 1, okay, you have to configure the IKE Phase 1 policy. And again, Cisco calls it the ISA-KMP policy. All right, so IKE Phase 1, some people call it IKE, some people call it ISA-KMP. It's basically Phase 1 of IKE, where you're establishing the secure tunnel to then negotiate your other parameters for how you actually want to encrypt your actual traffic. So basically how you configure that is you specify the word crypto is a KMP policy. You define some kind of priority because you can define a number of different policies. Typically, people really only do one. Sometimes they have multiple ones if some of the customers have a lot of different requirements. Keep it to the minimum amount if you can. You know, I mean, if you use SHA-1 for your hash function, you use triple DES or AES, and you have a lifetime of, I don't know, pick a week maybe, you know, generally that's good enough for everybody. The only time that you really would have different policies is maybe for different customers or different places, you have a vendor that will not interoperate for some reason with these parameters. And then what you can configure are the encryption algorithm, right? So your DES, triple DES, AES, your hash algorithm, typically your MD5 or SHA, the authentication method, and then your group lifetime. The next thing you do, okay, you configure an ISA-KMP identity, okay, so IKE Phase 1 identity. So you've got 2 IPsec peers, and they have to say who they are. Well, you either specify a name or you specify an IP address. More common than not, people use IP addresses because, quite frankly, there's more bugs if you use a host name. Okay? I mean, reality of the thing. So use an IP address to specify your ISA-KMP identity. Step number 3, you now configure your authentication or your your authentication header or ESP parameters, and you do that with the command crypto IPsec transform set. You have a name, and usually, maybe if you just want to protect BGP, I would just say crypto IPsec transform set BGP, and you define a transform set. Whether or not you have tunnel or transport mode, it's another line, and then you define the lifetime. Okay, so for your IPsec AH or ESP parameters, those are the 3 lines that you need to configure. So you need to just name a transform set, you need to define whether or not you're in tunnel or in transport mode, and then define some kind of a lifetime. And then step 4 is the traffic selectors. So which traffic are you trying to protect, right? Is it all traffic going from one network to another network, right? From a host to a host? Do you actually care what application it is? So any host on this network, that's Telnet and SNMP traffic, right? So essentially it's a filter. You're defining a filter that will say, okay, any traffic that meets this requirement, okay, this is what IPsec security services are going to be applied on. So then another thing you have to do is you have to configure your IKE phase 2 parameters, and that's your IPsec security association in Cisco speak. And what that is, that defines what algorithms and parameters you use for actually protecting the actual traffic. So for example, if I said that everything from subnet A to subnet C will have to, be IPsec protected, well, how? Right? So what am I going to use for my use for my transform set? What am I going to use for my encryption algorithm? What am I going to use for my authentication algorithm? And so how you define that is you define a crypto map, and with a crypto map, you basically say, okay, I'm going to be using IKE, and that's IPsec is a KMP, okay? Again, it's really convoluted, but IPsec is a KMP because is a KMP is the framework for the Internet Key Exchange, right? How to do key establishment and negotiation. They decided to use that terminology. Okay, I wish everybody would just use IKE, because anybody that uses is a KMP, I think it gets really convoluted. So what you're doing is you're just saying, okay, I want to create a crypto map, name this, that will essentially do IKE phase 2. And it needs to match the address, that's your filter address. All right, so the match address is your access list, your filter that defines your traffic selectors. And then you set the peer, which is the other end. So who am I, talking to? And typically it's the IP address. And then you define the transform set that you defined in step number 2. It's 3. Okay, so this transform set is what you then define over here, because these are the parameters that you're going to be using. And then you set the lifetime, and then you set the perfect forward secrecy, and whether or not you want to use Diffie-Hellman group 1 or group 2. So group 1 again, is like 768 bits, group 2 is 1024, and that's how big your prime numbers are. And so one point that I want to make, and this gets kind of confusing. The transform set, what that is when you're defining it in step 3, your IPsec AH and ESP parameters, right? That's your IKE phase 2. Begin to understand why I really hate this terminology that vendors use, right? Because if everybody just used IKE phase 1 and IKE phase 2, I think it would be a lot more clear. But no, everybody's got to create their own terminology here. So anyway, you can, peruse this later and, see whether or not you grok it. And if some of you really, want to understand it, you kind of want to get it now before you go home and you don't, again, I'm going to be here till Wednesday morning, so we can always sit down over beer and, talk about this. So additional IPsec considerations are, what happens when dynamic IP addresses are used, right? People are using DHCP and, your IP addresses change. And how do you actually authenticate users as well as devices? So these are issues that, there are no standard versions of doing this. A lot of vendors have, as a de facto, used what's called the XAuth extension, which is not, it hadn't become a standard, but it was one of the ways that people can actually do user authentication when you're using IPsec. And basically, you just do an additional negotiation to then get user credentials and authenticate before you complete the IKE Phase 2 process. So what time is it? I have a little bit of time left. So, again, I will have some configuration examples later for some different devices on there, just because I think it makes it easier. But there really are not any cookie cutter methods, okay, to do security and say, okay, here's a configuration if you have an extreme switch, here's a configuration if you have NetScreen, here's a configuration for your checkpoint. What you need to know is what are the things that you need to think about to then incorporate into your particular policy and what you're going to configure, right? Because any template that I show you, I'm going to pick something like I'm going to say, I'm always going to use SSH. And then you're going to be in an environment where, I don't know, for some reason, you have something that doesn't support SSH, right? So please, please, please just understand that any kind of templates that you will later see, right, if you're going to cut and paste some of that, which, people do, that's why I'm very careful before I create templates, because people will just use them. And I really hope that they actually understand what they are cutting and pasting, okay, in their environments. Now, none of you may do this, but I have heard of a lot of people that have done this, which is why I'm extremely careful when I do any kind of a template. And while I'm thinking of it, I don't know if you guys are aware of this, but Barry Green and Phil Smith wrote an excellent, excellent book. They do work for Cisco, but it's for ISP Essentials. And it's really good for anybody that is sort of new to the ISP world, maybe, and it gives you really good information and best current practices from everything that deals with routing and running an ISP, and there's also a chapter on security. So, just wanted to mention that that's actually a pretty good thing to look at. And, for some people here, me, I used to be a Ciscoite. They still work for Cisco, but, they really care about how to have ISPs do the right thing. So, before you just say, oh, it's all Cisco-centric, look at the book and see what functionalities they point out. Because a lot of times, if a book is written and published by Cisco, we can't exactly sit there and, put Juniper configurations in or, another competitors. But if it's written such that the functionality is there beforehand, all you have to do is look at your other competing vendor and say, okay, well, what's the command to do this functionality? Okay, because you want to have the right concepts in place. All right. What these slides do, and I don't want to go over them in too much detail because, it gets kind of boring after a while. I'm sure I've talked enough about, auditing and looking at logs. But these are just some things, if you're new to logging and auditing, things to check, things to check in terms of what could be wrong and whether or not you might be under some kind of a security breach. What's becoming more of an issue for service providers, though, and you do need to understand this because you could have very visible ramifications for this, is if there's a security breach, right, what can you talk about? And who can you talk to? And, our legal system here in the U.S. is just so great that, all the lawyers want to get more and more money. And so they create all these interesting ways how they can get more money. And so part of it, you know, in the legislation, I mean, I don't know, a lot of people don't really understand networks in the government, right? They're working hard, they're trying, you know, and there's very good people trying to educate them. But there's a lot of laws that may or may not be put into effect where you really have to be careful about what kind of information you keep. And I'll make this statement again, I made it earlier today, that you know, somebody had posted somewhere that what they do is they just keep their logs for 30 days and then they trash them, like their radius accounting logs. And the reason was because they got burnt, I don't know how, months or years ago, by the FBI wanting, you know, logs. And, you know, it caused some issues in terms of privacy from the customers. So what they have decided to do was just keep logs for X number of days and then they trash them. Okay? So, you know, who knows where the legal system is going with this? But it's something to be aware of. Another good RFC to look at, if you haven't looked at it before, is RFC 3013, and it basically has some great recommendations for security services and procedures. You know, and most of these are just how to be a good network citizen, right? I mean, who's going to control that you do this kind of stuff? But a lot of really smart people have come together in a room to write down, you know, some guidelines that, you know, this is what they think, you know, really should be happening, and what ISPs should be responsible for. And, you know, when you're notifying customers, I mean, the hardest thing to do when you have a security breach is, you know, what kind of information do you give out? Because you run into this where you don't want to give out too much information because, you know, that could be, you know, problematic. And you don't want to give out too little information because that could also be problematic, right? I mean, everybody wants to know as much as possible, but sometimes you don't even have the information. And, you know, the most important thing when you're under some kind of a security attack is that you be able to get the time to rectify the problem. You know, and you're going to have all these people, I mean, you're going to be the ones that are knowing what's going on, and you're going to be trying to fix your network, and you're going to have all your managers and all these people going, hey, what's going on? Hey, you know, tell me. Hey, I got to tell my customers. And, you know, you have to be very, very aware of what will happen and who gets to talk to who and what kind of information is relevant. And that's it. So, about 10 more minutes ago, so I'm a little early. But if you have any questions, like even right now, or there's anything that you might feel that, you know, you want more information on, I would like to hear about it. So if any of you have any comments right now, you know, please step to the microphone. One of the things that I always want to know about is what is one of the biggest problems that you have in terms of some equipment that you're getting from a vendor? And yes, I mean, I think the biggest problem is that configuration of security parameters is simply a nightmare, and it should be made easier. But, you know, apart from that, you know, is there anything that you think would be useful for the community, you know, in terms of security? And again, there will be the security BOF tomorrow night that I will moderate with Barry. And, you know, that's usually been a really good session for ISPs to be able to talk to each other and to share information. And especially also with the latest security breaches that are going on and how to best mitigate some of these attacks, because they're just increasing. So anybody have any questions? All right, that's it. Thank you very much.